Hey everybody, Mr. Quick here. Today we're going to be looking at Eureka Math / Engage New York Math, Module 4, Lesson 32, Multi-Step Problems in the Real World. So what we're going to do is we're going to look at some real-world problems that are represented in a table or a graph. We're going to determine what the independent variable is. We're going to determine what the dependent variable is. And if we need to, we're going to solve or evaluate the equations. So let's go ahead and get started. But first, a quick reminder that the independent variable is the thing that changes. The dependent variable depends on what the independent variable is. So if you say, every day I make $1, well, in one day you would make $1. You can't change what you make in a day. But you could say, how much money do I make in 6 days? Well, your answer over here depends on how many days we're talking about. So your independent variable is the thing that you can change. Your dependent variable changes based on what's over here. Okay, let's go ahead and get started. Use the bar graph to determine which variable is the independent variable and which is the dependent variable. Then state the relationship between the quantities represented by the variables. So we can look at our title here and we see that someone is going on a road trip. This is the number of hours they have driven. This is the number of miles that they have traveled. So we can see, obviously, they start at 0. In 1 hour, they've traveled 50 miles. In 2 hours, they've traveled 100 miles. 3 hours, 150 miles, so on and so forth. So we can tell that how far they drive actually depends on how long they drive. So the number of hours is the independent, I'll just put IND, independent variable, because you can determine, you can determine how far they drive. Sorry, I'm having some technical difficulties here. There we go. For any number of hours, we could find out how far they went, or how many miles they drove. If they went 6 hours, we could say 26 hours. We could say if they drove for 1,000 hours, we could find out how many miles they drove. So the thing that we can change is the number of hours. The thing that we can't change, the only thing that changes it is the independent variable, is the number of miles, and that is the dependent variable. Because how many miles do they drive? Well, it depends on how long they drove, right? So it looks like for every hour that they drive 50 miles. So we'll say 50 times the number of hours equals the number of miles. 50h equals m, when h represents hours that they drove and m represents the number of miles. So if they drove 5 hours, you'd say 50 times 5, and that would give you 250 miles. Okay, let's look at another example. Each week, Quentin earns $30. If he saves this money, create a graph that shows the total number of money Quentin has saved from week 1 through week 8. I've gone ahead and given that to you here. Write an equation that represents the relationship between the number of weeks that Quentin has saved his money, W, and the total amount of money in dollars he has saved. Name the independent and dependent variables. Write a sentence that shows this relationship. So I've actually given you a lot of it here because I just want to talk about it on this one. So if they do 1 week, $30 saved. 2 weeks, 60. 3 weeks, 90. So the total amount of money saved, S, is however many weeks they went times 30. So you get S equals 30W. Now, if you look here, the number of weeks is what we can change. We can determine how many weeks he's going to save his money. We could find out how much money he'll save for 9 weeks, or 90 weeks, or 1 week, or any number. So the number of weeks is our independent variable. The total he saves, you can find that out by looking at the independent variable. So you can look at the number of weeks, and that will tell you, once you've solved the problem, how much money he saved. So that is the dependent variable. Because how much did he save? Well, it depends on the number of weeks that we're talking about, right? So again, independent, dependent. All right, we'll do one more example together. Zoe is collecting books to donate. She started with 3 books and collects 2 more each week. She is using the equation B for books saved, or books collected, equals 2 times W plus 3, where B is the total number of books collected, and W is the number of weeks she has been collecting books. Name the independent and dependent variable, then create the graph to represent how many weeks. So I went ahead and showed you what they've done here. And one of the main things I want to look at here is so essentially it's 2 books each week, but we have to add in that 3. So that's why we have the number of books is 2W plus 3, because she didn't start out with 0 and just start doing 2 a week. She started out with 3 and then started doing 2 a week. So how many books did she collect? Well, that depends on how many weeks we're talking about. So because that depends on something, number of books is going to be the dependent variable. The number of weeks is going to be the independent variable. And what I want to also point out here on the chart is they don't start it at 0 and go up that way, right? They start here at 3 because that's how many she started out with. So she started out with 3, and then each week adds 2 more. Okay? So we're going to talk about more examples like this together in class. I just wanted to give you some examples to look at and to be able to go back and quickly reference on the video. So thank you for watching. We'll talk to you soon, and I hope this helped, and I'll see you very soon. Bye.